Welcome to the 11th part of VCAA Mathematics 2020 exam paper series. In this video, we will present exam paper 2, section B, question 4, which consists of 5 parts. Apart from part A and part C, the rest of parts were not scored well. Common mistakes include transcription error, incorrect use of brackets, inability to connect information to answers in early parts, etc.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Mathematics exam paper series. This is section B of 2020 exam 2 paper. There are total 5 extend response questions in section B. In this video, I will present you the 4th extend response question here. In question 4, based on its graph and the function f of x equals 2x multiplies e to the result of 1 minus x squared, where its domain is over the closed interval from 0 to 3. There are 5 parts in this question. Part A is to find the slope of the tangent to f of x at x equals 1. Part B is to find the obtuse angle that the tangent to the f of x at x equals 1 makes with the positive direction of the horizontal axis. Part C is to find the slope of the tangent to f of x at x equals p in terms of p. There are 2 subparts in Part D. Subpart 1 is to find the value of p for which the tangent to the f of x at x equals 1 and the tangent to f of x at x equals p are perpendicular to each other. Subpart 2 is to find the coordinates of the point where the tangent to the graph of f of x at x equals 1 and x equals p intersect when they are perpendicular. Now, 2 line segments connect the points 0 f of 0 and 3 f of 3 to a single point Q with coordinates n f of n, where n is between 1 and 3, as shown in the graph. There are 3 subparts in Part E. Subpart 1, the first line segment connects the point 0 f of 0 and the point Q, where n is between 1 and 3. The question in subpart 1 is to find the equation of this line segment in terms of n. In subpart 2, the second line segment connects the point Q and the point 3 f of 3, where n is between 1 and 3. The question is to find the equation of this line segment in terms of n. Subpart 3 is to find the value of n, where n is also between 1 and 3, if there are equal areas between the function f of x and each line segment. Since the function f of x equals 2x multiplies e to the result of 1 minus x squared, where x is within the closed interval from 0 to 3. So, for part A, its derivative function can be obtained by applying the chain rule, which is simplified to 2 multiplies 1 minus 2x squared, or in parentheses, multiplies e to the result of 1 minus x squared. Hence, f prime of 1 equals 2 times 1 minus 2 times 1, or in parentheses, times e to the 1 minus 1, which equals negative 2. As for part B, we assume the obtuse angle is alpha. So tangent alpha equals negative 2, which gives alpha equals 180 degrees minus arctangent of 2, which approximately equals 117 degrees. In order to find the slope at the point x equals p in part C, since f prime of x equals 2 multiplies 1 minus 2x squared, or in parentheses multiplies e to the result of 1 minus x squared, as we have found in part A. F prime of p equals 2 multiplies 1 minus 2p squared, or in parentheses multiplies e to the result of 1 minus p squared. Since we have already know f prime of 1 equals negative 2, the rule for f prime of p and the rule of f prime of 1. Since f prime of 1 is perpendicular to f prime of p, then in subpart 1 of part D, they have the relation that f prime of 1 multiplies f prime of p equals negative 1. Hence, we have this equation established. 4 multiplies 1 minus 2p squared, or in parentheses multiplies e to the result of 1 minus p squared, minus 1 equals 0. Solving this equation using CAS graphic calculator, we obtain the value of p, which approximately equals 0.655. Subpart 2 of part D is to find the coordinates of the point where f of p and f of 1 intersect. Since f of 1 equals 2 and f prime of 1 equals negative 2, that gives the linear equation y minus 2 equals negative 2 multiplies x minus 1, or in parentheses. So we have two linear equations established to calculate the coordinates of the intersection. One is established at the point 1, f of 1. The other one is established at the point p, f of p, as both of them can be seen from the diagram. After substituting the value of p, which was obtained in subpart 1, we solved the simultaneous equations to find the coordinates of the intersection. X equals 0.803376, y equals 2.39325. Part E has three subparts. Subpart 1 is to find the line equation connecting points 0, f of 0, and n, f of n, in terms of n. Generally speaking, the line equation can be established based on any given 2 points. So we have y equals f of n minus f of 0, all over n, times x, then plus f of 0, which equals f of n times x over n, which equals 2 times e to the result of 1 minus n squared times x. So y1 equals 2 times e to the result of 1 minus n squared times x. Since subpart 2 is to find the line equation between q and point 3 f of 3 in terms of n, and f of 3 equals 6e to the negative 8, the gradient m2 equals f of n minus f of 3, all over the result of n minus 3, which equals 2n times e to the result of 1 minus n squared minus 6e to the negative 8, all over the result of n minus 3. Hence, we have the line equation as shown on the screen. After being simplified, the line equation becomes y equals 2n times e to the result of 1 minus n squared minus 6 times e to the negative 8, all over n minus 3. Then times x minus 3, all in parentheses, then plus 6e to the negative 8. The question in subpart 3 is to find the value of n if the two shaded areas are equal as shown in the diagram. Hence, we have the equation of the two equal areas. The integral from 0 to n of f of x minus y1, or in parentheses with respect to x, equals the integral from n to 3 of y2 minus f of x, or in parentheses with respect to x. After substituting the functions for both y1 and y2, we may use the CAS graphic calculator to solve the equation and obtain the value of n, which approximately equals 1.088.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.